Thank you very much for the introduction, Pete. And I feel very glad and honored to be here to give the presentation and introduction of the work we have done with the Microsoft. So again, I'm from Microsoft Cloud and AI organization. My name is Le Zhang, and I'm a data scientist here. And I'm based in Singapore. So today, the topic I'm going to discuss about is recommendation, right? So basically, it's a open source project. We have been working closely with a lot of, you can see here the acknowledgement, right? So they are basically from different teams within our organization. They are researchers, developers, software engineers, and data scientists. So yeah, this is the objective. So taking recommendation technology to the masses. So actually, this was inspired by one of the exhibitions from Museum of Pop Culture in Seattle. So actually, the original statement is taking the punk music to the masses. So that was to like the respect to the very famous rock band of Nirvana, right? So we are actually we have been inspired a lot by this kind of statement because when we talk about the AI technology, we want to like make sure that everyone can benefit from that, right? It's not like the recommendation or whatever the AI technologies. It's just something like withheld by the big tech companies like Microsoft or Google, whatever, right? So it doesn't make sense. So this is why we want to like make sure that after we have open sourced everything about the recommendation, study, and research, we want people like researchers, developers, they can benefit from the repo to like prototype or demonstrate or even put things into production for their own use case, right? And the key takeaways of the talk is that I know actually the talk here is a little bit technical. It can also be a little bit academic, but I would say that all of these are the state of the arts, and all of these are the things that I want to share with you, because these are the core technologies, in my opinion, that are used in a lot of the recommendation system in the nowadays industry. So the outline will be that, first of all, I will just give you a very, very brief overview of the recommendation technology and how this technology is used in the modern business. And then after that, I will talk about the recommendation algorithms and the implementations. So all of those things I would talk about, they are available in the recommendation repository we have developed. And then the third one, I'll talk about some end-to-end example. I mean, these are the real-world examples that can make sure the recommendation algorithms can be put into production system, especially by using our Microsoft Azure platform. And then maybe there'll be several minutes for question and answers. Okay, so recommendation in modern business. So we know that actually recommendation can be found everywhere. So if you take a look at all of the logos here, so there are bunches of companies that apply the recommendation technology to like boost their own business. Like for example, Microsoft, if you're aware, the Bing News and Bing other search engine, actually they have been applying recommendation technology for a long time, right? So several other use cases, like if you're aware of the e-commerce or entertainment, like the video recommendation or product recommendation. So it's almost everywhere. When you open your app, you go to the website, you can see a lot of recommendations here and there, so that you can, these recommendations can be personalized, and they can be precisely, directing you to the right place where you can find the things that are interesting to you. So what are the problems they are trying to solve when they apply the recommendation technology? So basically, there are three things. So the first one is that the so-called the item recommendation, right? So if this is the, I would say the more academic terminology, but so the item here can be referring to brand, news, product, depending on what kind of industry the recommendation is used for. And basically, it's just to like recommend a certain item based on the historical interaction results between the users and the items. And the second one is the business metric prediction. Like a lot of times when we talk about, for example, ads, right? So you can predict how the the advertisement of your whatever can be improved by using the algorithms. So recommendation technology can be used here for predicting. Let's say you have ads of an image or whatever forms, and maybe the algorithm can like help you to figure out where you can put the image on your website so that the sort of the internet metrics like a CTR can be maximized. And the last one is the customer segmentation and personalization. So this is more related to the marketing campaigns, right? So for example, if you want to like target your product precisely to a group of people, you want to like apply this kind of technology to do that. However, whenever we talk about the recommendation, there are, I mean, according to my, as well as my team's experience working with the customers and clients, so there are basically three challenges in general. So the first one is that there's very limited resource for people to like reuse to, in order to establish a recommendation system. So these can this can refer to like the reference or any guidance or especially the industry level guidance. No, I'm not talking about the academic research paper because if you go to archive you can see a lot of publications every day, but I don't think all of them can be used practically into your production system. So what I want to say is that there's very limited reference for you to like from a pragmatic perspective, how do you like develop a recommendation system in a very efficient manner, right? So this is the first challenge. The second one is that although we can also find some packages like libraries or anything that has been published on GitHub or wherever, however, they are very fragmented. So it means that it's hard to like, for example, you can find a lot of algorithm implementations off the shelf, but if let's say you want to make a whole system, I mean, it may consist a lot of different parts, but algorithm implementation is just one part of it. So how can you, aggregate everything together in order to make a whole system? That is a very big challenge. And the third one is that the area is growing very fast and it's changing all the time. And as I said, I mean, if you go to the academic research paper, if you go to the community, you can see that a lot of people, they're talking about new algorithms every day, right? So later on, I will go through a few algorithms to just demonstrate that how the field is dynamic. Okay, so then this is the motivation why we want to have this kind of open source effort that can, resolve the issues I have listed in the previous slide, right? So this is something we call a Microsoft recommender. So it's basically a GitHub repository. And if, let's say, if you go to the GitHub repository, you can see that this is like, you can find all of the codes, you can find all of the references, text, and explanations, and the end-to-end examples that can really help you like resolve a lot of issues that may, block you in the way to productionalize your recommendation system. So this is a collaborative effort between Microsoft data scientist team as well as research team and also some external academic researchers. They have participated into the project as well, and it provides a bunch of very cool algorithms, including the classic algorithms like matrix factorization, as well as the new ones like how do you use the deep learning technology to build the new types of recommendation system that are, specifically working for a particular task, right? And so a few highlights about the project is that actually so far it was open source last year in December, and now it's got 3,000, actually it's 3,800 plus stars in GitHub. So, and also it was featured in YC Hacker News, O'Reilly Data Newsletter, and also it was once in the list of the GitHub weekly trending list. Okay, so again, I mean, if let's say you're open source community developer, or if you're interested in contributing to the repo, just feel free to go to the repo, to go to GitHub to like create whatever issues you found like when you either work with the repo or you just go through a repo and you can just create any PR if you think you can like improve the repo in whatever way. All right, so let me just go through the recommendation algorithm and implementations. So first of all, I would like to ask. Actually, I should have asked this one at the beginning of this the talk. So how many of you are working recommendation? Okay, great. And have worked in recommendation. Okay, yeah, okay, never mind. So, all right, so then I'll just try to make it short because some of the algorithms are maybe a little bit more advanced than, yeah, so whatever. I mean, recommendations. So we know that when we talk about recommendations, there are typically two types of recommendations. So the first one is so-called collaborative filtering, right? And the second one is that actually I have already added to the slide on my laptop, but I just didn't have the chance to update the ones here. So the second one is the content-based filtering, right? So later on I will show you how different they are, and basically we have this bunch of algorithms for collaborative filtering and content-based filtering. So collaborative filtering. So when we talk about recommendation, let's take a look at the figure here, right? So suppose this is one like yourself, and you have watched a few movies, right? So let's say the three one. And maybe your friends A and B and C, they have watched some other movies, right? So the logic of collaborative filtering is that the algorithm will try to like analyze the similarity between your preferences and your friends' preferences, and then sort of find the similarity and analyze how close the friends' preferences are to your potential preferences, right? And then those potentially interesting movies will be recommended to you. So it's very simple. I mean, it's something. Why it's called collaborative filtering is because within the population of all of the users, you just collaboratively find out the similarity across all of the users and the recommended items, right? So then there are basically two types of methods for collaborative filtering. The first one is the memory-based. So again, I mean, the memory-based algorithm, technically, it just find the similarity and save that into the matrix, and then use the matrix to give you the recommendation results, right? Well, the second one is the model-based method. Model-based method solve the problem in a machine learning type of approach. So it means that it just try to like find out the similarity and develop a model that can optimize the loss function, right? So if you're familiar with the concept in machine learning, so the loss function is usually the objective that you want to optimize in your problem. So in model-based methods, usually like in the recommendation scenario, the things that is going to be optimized is, for example, the ratings of the movies, or the ratings of the products, or the ranking, like a list of the items that are relevant to the user. So this kind of thing, right? So the model-based methods, they're trying to solve this kind of problem, and there are many different kinds of model-based methods. So one of the classic, very representative methods is called the matrix factorization, right? So if you're aware of the mathematical term, is basically based on the singular value decomposition, right? So this is the basic method that is used for matrix factorization. And then people come up with some other advanced technology that can resolve the efficiency issue in optimizing the matrix factorization problem. So that's called ALS, alternating least square. And also this can be implemented into Spark, which is more scalable. So this is the first type of the matrix factorization. And also a lot of new techniques that brought these years, they try to use the deep learning technologies to build the collaborative filtering type of models. For example, the retrieval Boltzmann machine and neural collaborative filtering, right? So again, this is the memory method. I don't want to go through all of the formulas here, but I want to just simply introduce you that so the core idea of the memory-based approach is just to calculate the similarity, like for item or for users, right? Depending on what kind of scenarios you're trying to apply the recommendation algorithm in, right? And usually the similarity calculation method is, for example, Pearson or cosine similarity. Then after that, you can use the similarity scores to recommend the items. I mean, you can just like sort of ranking all of the scores and then recommend the items or to the users, or recommend the users to the items. So I want to like go into some details about the algorithm that is invented by Microsoft. It's called the Smart Adaptive Recommendation. Actually, it's a very, very super simple idea. So it's just like, again, it's a type of memory-based algorithm. So it's just try to analyze the implicit feedback data, which means that suppose that you have a lot of interactions with the items, and how you can utilize this historical data to recommend the items. So remember, the uniqueness of the problem is that you don't have the ratings here, right? So you don't have the, for example, from some of the data, let's say IMDb, right? So if you go there, you can see a lot of ratings to the movies. But this kind of problem, there's no such kind of rating. So how to do that? So it's very simple. So you can still, you build the item-to-item similarity matrix. So this is done by calculating the co-occurrence of the items. Let's say there are several items, they appear together to the user, and then they'll be counted, right? So this is the way to like build an item-to-item similarity matrix. Another very important matrix is the user-to-item affinity matrix. So this is something to represent how a user likes a particular item. So this is done by, again, very simple, counting the co-occurrence between the user and the item. Like, for example, how many times you have purchased this product, and then they'll give you the score by using the count, right? But another thing that is very important to mention here is that because when we talk about the recommendation, we know that, for example, this guy, he has purchased the item last year, and then he purchased again this year, or maybe something different this year, right? So the point here is that actually the preferences reflected from his purchase behavior in the recent, months or days, that will be more important. So that will be weighted more in our recommendation problem settings, right? So this is why in the affinity matrix calculation, the time decay is introduced to model this kind of effect, right? So then when you do the recommendation, actually it's very simple. Just do the matrix multiplication between the item similarity and the user affinity. And then you can have all of the recommendation scores. You rank the scores, and then you get to the top K items in the top ranking of the list, and then you just use that as the recommendation. So what are the benefits? Actually, it's very simple, right? As I have introduced just now, is a memory-based algorithm in the first place. So it's free from machine learning. You don't have to train your model. You don't have to like tune your hyperparameters to this and that. So it's just calculating from the data, and then you can generate the results. And also, it doesn't require you to collect the features. And the best part of the algorithm is that it's explainable, because for example, this guy has purchased this item for many times, and most of the purchases happen in the last month, right? So you can sort of explain, this is why I recommended the items to him again, right? So this is the point. But the disadvantage is that actually the calculation itself can be expensive, and also you have to preserve the affinity matrix as well as the item similarity matrix. So both of them can consume a lot of memory, especially when you have a very big data set, right? So imagine that you have a lot of items, a lot of users. So this can be the challenge. Yeah. So here I've also shown some code examples in how to use the so-called SAR algorithm from our repo. So it's very simple, like just exactly how you do with other Python packages. Like you can import the package from the repo, and you can just import the method to build a model. And yeah, so this is the first part. You can just prepare the data set and fit a model, generate the top K recommendations, and then do the evaluation by a few offline evaluating metrics like the precision at a K and DCG at a K, blah, blah, blah. Right. Okay, so let's move on to the next one. Yeah, so this is the matrix factorization. So just now we talked about memory method, right? So then the model-based method, one of the classical representatives is a matrix factorization. So idea is very simple again. I mean, it's just to like, for example, you have the user item matrix representing the data ratings. So the job is to like factorize this matrix into two vectors, right? So one is user, another is movie, so that you can when you do the product of the two vectors, you can sort of reconcile the original matrix. Uh, then you can have all of the ratings predicted from the two vectors, right? So this is the idea. It's very simple. So I don't want to spend too much time on that. And but one of the more advanced algorithms, actually, this is one of the very recent research. Um, so this is called the neural collaborative filtering. So it tries to solve the problem from the matrix factorization that when you deal with the implicit feedback data, remember just now I mentioned the implicit feedback data, right? So that is the data where you don't have the explicit ratings between users and items. You just have the interaction, right? And for this kind of thing, the author point out of the problem that when you have this kind of settings, actually, when you put it into the latent space, there can be some problem because you cannot fully represent the relationship between each of the factors. So that is why he introduced something called a generalized matrix factor layer by using the neural network technology, right? So this can sort of resolve the issue that exists in the original matrix factorization based method, right? And then to sort of model the high order interactions in the data. He also introduced the multi-layer perception in the neural network as well. So then he put the two things together and fed into the last layer of the activation function to predict the scores. And in the training part, he also suggested a few loss functions like log loss or other type of loss in order to fit the actual problems. So again, I mean, in general, the advantage of this algorithm is that it leverages the benefit of neural network in order to resolve the issue of the original algorithm. So then the second category is something called a content-based filtering. So content-based filtering is different from the collaborative filtering is that it actually uses the features to predict the ratings or any other labels in the recommendation algorithm. So for example, this guy is his age, his gender, his occupation, or other meta information about the person, or the features of the items, and then you can use all of them in order to predict whether this guy likes the movie or not, or you can predict even the explicit ratings of the guy on the movie, right? So this is the Euro setup of the content-based algorithms. So again, actually you're looking for a model that can sort of fit the input data, which is usually encoded in this way, to like predict the label, which is binary label or numerical label. So a few algorithms. The first one, the most representative content-based filtering algorithm that is used nowadays is called a factorization machine, right? So as you can see that these are the features, and you have ones, zeros representing different types of features. So here is the movie data. You can see that the user ABCD, there are different users, movie, and these are the titles, abbreviation of the titles, and genres or whatever information, right? So then they organize the data in this way to predict the target Y here. So these are the ratings. So the idea is that actually it introduces the high order interaction between the features, right? So the way of doing this is that when you do the factorization, when you do the no, not about the factor. When you do the, for example, linear regression, you cannot have the interaction between the features, right? So this is why the factorization machine is trying to do that, right? Again, I mean, I don't think I have enough time to go into the details, but this is usually nowadays. I mean, a lot of industry applications, many of the algorithms are based on this kind of. Many of the applications they are based on this algorithm, okay? And then on top of that, people like come up with new technologies from FM. So they are, for example, a more product for introducing the interaction of the features. And Google, they have come up with the wide and deep, so they just have two parts. One is the interaction part, another one is just purely the linear regression. And then they aggregate them together and train the model to get a much better result for particular applications. And also DeepFM, they introduce deeper neural network in order to have some more high order interactions. So also one of our colleagues from Microsoft Research Asia, they also have developed a new algorithm called the extreme deep factorization machine, right? So they want to have even higher order interactions so that they iteratively like introduce the product between the inputs and the output from the input by introducing some pooling layer. Okay. Then the whole idea is that we just combine everything together, including the one I introduced just now. It's called something called a compressed interaction network, and linear part of the things together so that they can have a better prediction result. So also a lot of times people are talking about knowledge graph. So knowledge graph can be used for recommendation as well because it can have much more useful information for the items and users. So a few techniques used for knowledge graph is that you can basically introduce the embedding and use the embedding into your neural network in order to have a better prediction results. And especially, although in this work, and I mean the deep knowledge aware network is not mentioned, but a lot of times the knowledge graph is also used for enhancing the explainability of the recommendation system. Okay. So the last part is the end-to-end example. I just want to quickly go through that one. So, okay, yeah. So just now I talked about a lot of the algorithm, but in reality, the time and effort spent on building a recommendation system, in my opinion, they're actually something like this. I mean, you spend most of your time on preparing the data and cleansing your data in order to make sure data can be used for building the model. Well, the algorithm is actually a small part, right? Another important thing is for recommendation is the evaluation. And the last one is how you can put everything together into the system. That's called operationalization, O16N, right? So these are the four major parts for building the recommendation system. And how do we usually do that? So when we do the operationalization, we do the data collection, data preparation, and model building. So in the model building, one thing I would like to highlight here is that usually for the recommendation, it's very, very important. Let's say if it's model-based algorithm, it's very important to fine-tune the parameter in order to make sure the model is optimal. And then deployment of the model, you can either use Kubernetes, container, or you can use large distributed database in order to host all of your data in a very efficient way, right? So this is an example of a real-time recommender by using distributed database. Actually, this is done on the Azure Cosmos DB. So if you're interested, again, I mean, just go to the GitHub repo. You can check all of the details. Well, here I just give you a very, very high-level overview of it. And then the next one is the Kubernetes. So I'm not sure if you're familiar with the technology. I believe so, but what I want to highlight here is that in the recommendation system, there's usually two typical scenarios. One is the real-time scoring, real-time recommendation. Another one is you cache the data into, you cache the recommendation results into the database, and then use your hosted service to perform the recommendation. So both of the two will rely a lot on this part, I mean the serving part, which is usually based on the Kubernetes, right? So you need to properly configure the cluster in order to make sure everything works well. So this is everything put together, and on Azure platform, you can have a recommendation system architecture like this, right? So you use Spark to train the model, generate the results, and put it into Cosmos DB, which is the distributed database. And then the Kubernetes, Azure Kubernetes services, it just fetch the pre-cached results from the database to serve the user clients, right? And over here, the Azure Machine Learning Services is something like to, again, just now I mentioned that you need to fine tune your model, you need to like orchestrate the pipeline. So Azure Machine Learning Services is just something like this to help you do that. Okay, so this is some load testing on a real example. So I don't want to go to the details. Yeah, so summary, again, I mean, the talk is really give you a basic understanding, a systematic review, overview of how recommendation works and what are the classic and state-of-the-art algorithms and how we do the end-to-end example on Azure to build a recommendation system. So I will highlight that if you're interested, if you want to have more exploration on the recommendation technology, just go to our GitHub repo, Microsoft/recommenders, and go through all of the notebooks or utility functions and even the reference architecture examples to have a better understanding of it. All right, thank you. Do I still have time to take the answer?